All right, let's tackle this definite integral. Now we call this a definite integral because we have bounds of integration here. The 4 and the 8 are x values that we're going to evaluate this at. So the first thing we're going to do is go ahead and take the antiderivative. So I'm going to bring along the 6. We're going to increase the exponent by 1. It was a 1, now it becomes a 2. Divide by that new exponent. And then for our second term, the 10, we're going to put an x with that. And we can kind of double check this if we want to by taking the derivative of each one of these terms. If we take the derivative of this first term, we should get the 6x back. Derivative of the 10x should give us the 10. Next, I'm going to go ahead and include our bounds of integration. So that vertical line, and then include these bounds of integration afterwards, saying we still need to evaluate it at those values. Now I'm going to think of the 6 over 2 as being 3. And we're going to evaluate this first at the upper bound at the 8. So I'm going to think 3, and then 8 is going to get replaced in for the x. Same thing for this x. Then we subtract off when we replace each of the x's with the lower bound. So again, it's 3, 4 gets replaced in, 4 gets replaced in there. Now the other thing you want to take note of is because this is subtracted away, it's this entire function, I used a big set of parentheses to enclose this whole second evaluation when we put the 4 in. Why we have to do that is this negative has to be distributed to each one of these terms because there is more than one term in that function. All right, simplifying this down shouldn't be too bad. 3 times 64 plus 10 times 8 is going to be 80 minus, I'm going to keep my parentheses here, 3 times 16, 4 squared makes 16, plus 40. And then working this down, we get 192 plus 80 minus 48, and I'm distributing this negative in this step, minus 40. This all works out to be 184. But the final answer isn't the big consequence here. It's more so like, how do we do the problem, right? That the numbers could change, but the same process is going to work for a whole lot more functions. All right, so I hope this helps out. Good luck.